So in this part, we will learn how to, in dynamics part, we will look at bodies in acceleration. We will look at bodies in acceleration as opposition to statics. Okay? So first, what is new is that we will introduce the acceleration concept, and we will learn how to relate position, velocity, and acceleration. Okay? And in a next step, we will learn how to relate forces to acceleration by writing the second law of Newton, sum of forces equals to ma. Okay? Now, in the first chapter, we will not consider forces. In the first chapter, just we will relate position, velocity, and acceleration. This is called kinematics of a particle. Then when we relate forces to acceleration, it is the kinetics part. Okay? So for the first chapter, we will deal with kinematics of a particle. We will learn how to relate position, velocity, acceleration, how to deal with motion in straight line, curvilinear motion, projectile motion. Okay? So to begin with, let us start by the simplest case, which is rectilinear motion. Okay? When you move along a straight line. If you are moving along a straight line, you just need a single coordinate axis to define your position. Okay? So let us look at the figure here. I am moving on a straight line like this. So this is my motion. Since I have motion on straight line, I need a coordinate to define my position. So I can choose any origin on this line. I choose an origin, which is my reference. And I can say that the position of my vector can be completely provided by the coordinate s. S can be positive or negative. So if S is positive, I am to the right of O. If S is negative in this zone, I am to the left of O. Okay? Now, once I define the position vector, so OP is called position vector. I can define velocity based on this. Because first, to define velocity, velocity is related to displacement. Okay? Displacement is the change in position. So if I want to calculate displacement from 2 points, 1, 2, delta S between 1 and 2 is simply S2 minus S1. Okay, so the variation from a certain position to another one. Now, to calculate the velocity, we have several definitions of velocity. We have average velocity and we have instantaneous velocity. First, what do I mean by average velocity? If you look at the figure here, you have this is point 1, this is point 2, and you are moving from 1 to 2. Okay? So when moving from 1 to 2, you are doing a certain displacement delta S. Delta S is equal to S2 minus S1, okay? And then the average velocity when going from 1 to 2 can be defined as following. V average is delta S over delta T, okay? Now, if I take a very small time step, so if delta T tends to 0, if this delta T tends to 0, then I can calculate instantaneous velocity. So instantaneous velocity is given by the derivation of position with respect to time. Okay? So V instantaneous is ds by dt. Now, for the instantaneous velocity, like the average velocity, it can be positive or negative. It will be positive when the particle is moving to the right. Why? Because the sign of V depends on the sign of the displacement delta S. So when you move to the right, delta S is positive, so V is positive. And when you move to the left, then ds is negative and V is negative. Okay? Now, the magnitude of velocity is called the speed. We should also pay attention for a difference between what we call average speed and average velocity. What is the difference? First, in the last slides, we have seen that the definition of average velocity depends only on the initial and final position. So I said if I go from 1 to 2, then V average between 1 and 2 is delta S over delta T. So for example here, if my position 1 is here, and I go to 2, and I'm going in the left direction, then my velocity is negative, okay? To calculate V average, I only consider delta S. Delta S here is negative, equal to S2 minus S1, okay? Or if you want here, if they consider delta S a distance, this is why they put minus delta S over delta T. But in general, to be more general, delta S can be positive or negative. So if you take it as a distance, then you put minus delta S over delta T here, okay? So if you want here to be more consistent, the average here is minus the absolute value of delta S over delta T, because I'm going in the negative direction. So for you, always take delta S as algebraic value, can be positive or can be negative. Now, if I do this pass, if I choose to go first to the right, then go to the left, still my position 1 and 2 will not change. Position 1 and 2 will remain the same. So V average will not change. So you should pay attention for one thing, that V average does not take into consideration the path of motion. It just considers the initial and final position. This is why sometimes it will not give, if you want, very accurate predictions, because it will only be of common sense if you are going in one direction, if you are not changing directions. But if you are changing direction during your motion, the value of the average is not very representative, because look, for example, if you go from O and you come back to O, if you go and come back to the same point, the average will be what? Will be 0. So it seems like you didn't, we didn't do anything. We have stayed at O, which is not the case because we have moved. So this is why we define a new parameter that can help us to know if we moved or not, which is the average speed. Because the average speed considers the total distance traveled over time, okay? So, for example here, if I go first to the right, then I go to the left, then I will say that the total distance will be the following. First, I should take into consideration the distance I move to the right. Then I should add to it the distance I move to the left. So my total distance will be d1 plus d2. Okay, so in this case, I say that the average speed first for this example is equal to d1 plus d2 over delta t. So the first conclusion we can make is that the average speed is always positive. Always positive, cannot be negative because it's considered a distance. Okay, the distance is a positive number. Not like the displacement, the average velocity can be or positive or negative, as we said, depending on the direction of motion. Okay, if I'm going at the end to the right or to the left, so this will affect the sign of the average. However, the speed is always positive because it considers the total distance, which is a positive number, over the time. Now, the second conclusion we can say is that the average speed is higher or equal to average velocity, to the absolute value of what? Of average velocity. Why? Because look, they can be equal in one case only. What is the case? If I go straight. If I go straight, okay, then V average and average speed will be equal if I am moving in the positive direction. And if I'm moving in the negative direction, I will take that the average speed is equal to the absolute average velocity. Because if I'm going to the left, the average speed will be negative, the average velocity will be negative. However, the average speed will always be positive, but they will be equal in magnitude. Now, whenever I have a change in direction, automatically the average speed becomes higher than the average velocity, because in this case, the total distance will be much higher than, it will be of course higher than the displacement value. Okay, so here whenever I change direction, the total distance will be higher than the absolute value of displacement, so the average speed will be higher than the absolute average velocity. Okay, any question on this? I will stop here. Okay, and we continue next time. Bye bye.
Thank you, doctor.
Welcome.
Thank